Okay, hi everyone, welcome back to the Comptia Security Plus course. Network design. Proper network design is critical for the security of your network, servers and client computers. You need to protect your network devices so that they and the clients that they connect to will be less subject to attack. Implementing network address translation and properly employing standard private IP ranges can further protect all the computers in a standard network. A thorough knowledge of network zones, for example local area networks and demilitarized zones, is also important when designing a secure network. Finally, by utilizing sub-networks, virtual local area networks, VLANs, network access control and secure telephony devices, you can put the final touches on your network design. We start with a quick review of the OSI model. The Open Systems Interconnection OSI reference model was created and ratified by the International Organization for Standardization (ISO) and is represented in the United States by the American National Standards Institute (ANSI). This model was created to do the following: explain network communications between hosts on the LAN or WAN, present a categorization system for communication protocol suites such as TCP/IP, show different protocol suites can communicate with each other. Remember, network communications existed before the OSI model was created. This model is an abstract way of categorizing the communications that already exist. The model was devised to help engineers understand what is happening with communication protocols behind the scenes. Network devices. Let's begin with the network devices common on today's network. Central connecting devices such as switches need to be secured and monitored. It makes sense because these devices connect all computers on your local area networks. Attacks aimed at these devices could bring down the entire LAN, and of course routers are extremely important when interconnecting LANs and subnets. Because many routers have visible IP addresses on the internet, you should expand your line of thinking to include the act of securing these devices from attackers that might come from outside and inside your network. It is more common that attackers will be situated outside your network, but you never know. Switch. Ethernet switching was developed in 1996 and quickly took hold as the preferred method of networking, taking the place of the deprecated devices such as hubs and older style bridges. This is due to the switch's improvement in the areas of data transfer and security. A switch is a central connecting device to which all computers on the network can connect. The switch regenerates the signal it receives by default, sends the signal to the correct individual computer. It does this by mapping computers' MAC addresses to their corresponding physical port. This can effectively make every port an individual entity, thus securing the network and exponentially increasing data throughput. Switches employ a matrix of copper wiring instead of the standard trunk circuit and intelligence to pass information to the correct port. The Comptia Security Plus exam focuses on layer 2 and layer 3 switches. Layer 2 switches deal with MAC address only, but layer 3 switches work with MAC addresses and IP addresses. Most of the attacks we discuss are layer 2 based, but not all. Be ready to secure on both layers. Although the switch is an excellent star-based topological solution, some security implications are still involved with it. These include, but are not limited to, MAC flooding. Switches have the memory set aside to store the MAC address to the port translation table known as the content addressable memory or CAM table. A MAC flood can send numerous packets to the switch, each of which has a different source MAC address, in an attempt to use up the memory of the switch. If this is successful, The switch changes state to what is known as fade open mode. At this point, the switch broadcasts data on all ports the way a hub does. This means two things. First, the network bandwidth will be dramatically reduced, and second, that a mischievous person could now use a protocol analyzer running in promiscuous mode to capture data from any other computer on the network. Some switches are equipped with the capability to shut down a particular port if it receives a certain amount of packets with different source MAC addresses. For example, Cisco switches use port security, which can act as a flood guard among many other things. This restricts a port by limiting and identifying MAC addresses of the computers permitted to access that port. A Cisco switch defines three categories of MAC addresses three categories of secure MAC addresses as part of a policy on the switch. Other providers have like policies that can be implemented. Other ways to secure against MAC flooding and constrained connectivity include using network access control (NAC) and 802.1x compliant devices, dynamic VLANs, and network intrusion detection systems (NIDSS), and constantly monitoring the network. MAC spoofing. MAC spoofing is when an attacker masks the MAC address of their computer network adapter with another number. This allows a user to disguise their computer as a system on or off the network, thus flooding the switch and possibly gaining access. Cisco's port security feature and NAC systems and other application layer solutions can help to prevent this. But in the case of an insider attempting this, a router should also be configured only to accept a certain amount of static MAC addresses. This attack can be enhanced by initiating a DHCP starvation attack, which works by broadcasting DHCP requests with a spoofed MAC address, which can ultimately exhaust an address space available to DHCP servers. To help prevent this, enable DHCP snooping. Also close off any untrusted switch interfaces, meaning ones that connect outside the network or firewall. Finally, another related attack is ARP spoofing, which is when the attacker can make a system appear as the destination host sought by the sender with obvious repercussions. This can be prevented by reducing the time an entry stays in the ARP cache on the switch and on the clients, checking removing static ARP entries, using dynamic ARP inspection, and also using aforementioned DHCP spoofing. Physical tampering. Some switches have a dedicated management port. If this is accessible, a person could perpetrate a variety of attacks on the network. Even if a single port of the switch is accessible, a person could attempt an aforementioned MAC flooding attack and move on from there. In addition, if a person were to get physical access to the switch, that person could attempt looping, which is when both ends of the network cable are connected to the same switch, or when two cascading switches are connected to each other with two patch cables instead of just one. Plus, the potential for inadvertent looping grows with each additional switch. To avoid cable loops, consider the hierarchical switch environment. For instance, one where all LAN switches connect to the master switch, also known as an aggregation switch. Some switches come with the ability to enable loop protection with firmware. For example, you should enable the spanning tree protocol (STP), that is, if it isn't enabled by default. STP, as well as rapid STP and multiple STP, builds a logical loop-free topology for the Ethernet network and can recognize and bypass improper connections. However, it's preferable to prevent the problem from physically happening in the first place. So remember that the switch needs to be physically secured, most likely in a server room with some type of access control system, and all switches should be checked for internal cable loops. It sounds simple, but it is commonly overlooked. by many companies. Also, disable any unused ports on the switch if the switch has that capability. Finally, employ good cable management, label ports and cables, and organize patch cables as necessary. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.